elements R, Q, and P. These two sets are equal sets. So we can say that A is equal to B because they contain the same number of elements and the same type of elements, but they are not in order. So we don't put the order into consideration. But we can say that the two sets are equal. Equivalent set. Two sets are said to be equivalent if they have the same number of sets. In other words, if the length of set A and the length of set B are equal, the two sets are equivalent. If the number of elements in set A is equal to the number of elements in set B, the two sets are said to be equivalent sets. Let's look at an example. Set A contains the element 1, 2, and 3. Set B contains the element P, Q, and R. Now, these two sets are said to contain the number of elements in set A is equal to 3. Because the number of elements in set A is equal to 3 and the number of elements in set B is equal to 3, both sets are said to be equivalent. So set A is equivalent to set B because the number of elements of set A is equal to the number of elements in set B. Regardless of the type of element or the order of the element in the sets, what matters in equivalent set is that both sets have the same number of elements in them. The two sets can be said to be equivalent. Universal set. Universal set is a set that contains all the possible elements under consideration. When studying integers below 20, the universal set contains element x, so that x is between 1 and 20. And x is an integer. Set A is an example of a universal set because it contains all the elements that are under consideration, integers that are below 20. In the previous section, I talked about a universal set, but I didn't mention the notation for universal set. The notation for universal set is this symbol, or U. The notation for a subset is this symbol. So you can say that A is a subset of B. So a set is said to be a subset of another set if the elements that are in set A are also in set B. We say that A is a subset of B. So if A is a subset of B, X is going to be a member of set A, and X will also be a member of set B. Therefore, we can now say that set A is a subset of B because both sets contains the same element. Proper subset. So A is a proper subset of B if and only if A is a subset of B and A is not equal to B. If and only if A is a subset of B and A is not equal to B. So if A is a subset of B and there is at least one element in B that is not in A, it means that set A is not equal to set B. Therefore, A is a proper subset of B. The cardinality of a set is the length of a set, or the size of a set, or the number of elements in a set. And in notation is, if the set is A, this is the notation for the cardinality of a set. That means the number of elements in set A. The number of elements in set A. So for example, if set A is equal to A, B, C, D, and E, then the cardinality of set A, which is the number of elements in set A, is equal to 1, 2, 3, 4, 5, is equal to 5. The number of elements in set A is 5. That's the cardinality of the set. So let's apply the concepts that we have learned so far. So let's say we have a universal set such that the universal set contains numbers from 1 to 10. Or a set of integers between 1 and 10. This universal set can also be represented as